Okay, so we're going to prove that the area of a parallelogram is base times height, where this length here is a base, and then this length here is a height. And we should convince ourselves that this is just, this length is the same if this is, perpendicular to that imaginary line, and that, any line that's drawn perpendicular to these two lines is going to be the same as h. But okay, now, yeah, we want to prove that it's base times height, and we have b, we have h here. We know that this is perpendicular. So what we're gonna do is we're gonna make this construction, and we need to prove that this resulting construction is a rectangle. So what do? I take this triangle DAE, and I cut it out and I move it so it's over here. Now there's a few things that we need to go through so that we can guarantee that it looks like this. The first one is when I do this construction, how do we know that the two sides are going to line up, that AD is going to be the same thing as BC, that this lines up perfectly, that it doesn't, look like this, sort of. How do I know it doesn't look like that? And how do I know it doesn't look like this, right? There's nothing, I can't guarantee that it's going to line up perfectly unless I know that AD is going to be congruent to BC, that this length over here is the same as this length. And we know that. How do we know that? How do we know this? We know this by parallelogram theorem, which says that if it's a parallelogram, opposite sides are congruent. By parallelogram theorem, opposite sides are congruent. AD is congruent to BC. Okay, that's one thing. Now, the other things that we need to prove about this are that, well, we should convince ourselves that this angle is indeed a right angle. That's something that's sort of obvious, maybe not. But if we know that this is a parallelogram, right, I'm not going to write this, but that angle for sure is a 90-degree angle. Now, more difficult to see, maybe, is that if I take this angle over here, right, this angle that I'm trying to illustrate over here, this angle right here, right, you should see that it moves to over here. And I want to prove that that angle plus this angle over here is 90. And how am I going to do that one? Let's see. How can we do that one? So let's write this. So let's say that this is x and that this is y. Then this would be x over here. So how do we know that measure of angle x is plus measure of angle y is equal to 90 degrees? Well, let's see what we have here. We have, and I'm not remembering. Oh, here we go. Okay, I know the argument. Okay, so what is the argument here? So let's call this angle 1, and then this one over here, angle 2. Okay, that means that angle 1 came to over here, right? And we should see that 1 is the same as 2. Why is 1 the same as 2? Because they're opposite angles in a parallelogram. So then that's the same thing as y. I should just say that this is y over here, right? So 1 is the same as y. So how do we know? Let's start writing our argument. How do we know? Well, first I'm going to say angle 1 is congruent to angle y. And why is that? Since opposite angles in a parallelogram are congruent by parallelogram theorem. Opposite angles in a parallelogram are congruent by parallelogram. I'm just gonna write these two lines, parallelogram theorem. Now, let's see what else we have. Now I have that 1 is the same thing as this. Then I'm going to say, well, 1 plus x. What's the measure of 1 plus the measure of angle x? We should convince ourselves that this is 90. How do we know that that's 90? Well, this is a 90-degree angle, right? This is a 90-degree angle. So the sum of all three of these is 180. And if you minus 90 on both sides, you're going to get that that 90 goes away, and you're going to get that the measure of 1 plus the measure of x is 90. So take your time, make sure it makes sense so that you can see that. Now the next thing that I'm going to say, is, if I can move this, there we go. The next thing that I'm going to say is, well, I know that these two angles are congruent. So I know measure of 1 is equal to measure of y. And then substitute, and I get measure of y plus measure of x is 90, which is exactly what I wanted. I showed this fact. So now I know that this is a 90-degree angle. I'm not done yet showing that this is a rectangle. This is obviously a right angle over here. But I still need to say one last thing. I need to say that 1 plus whatever you want to call it, let's call it z, is 180. That this is a straight line. And that it doesn't look something like this. So these are my bad examples that they could be, right? But it could also look like this, right? It could fit, but it could look like that, where it's not a straight line here. That doesn't sum to 180. So I need to show that this is 180. To do that, I do a similar trick. So let's write down our statement. Let's write down our question that we're trying to show. How do we know that measure of 1 plus measure of z is equal to 180? Well, we know that because we know 1 is the same thing as y. So I'm going to write, measure of angle 1 is equal to measure of angle y. That we've already established over here, right? We should see that these two angles are congruent. We already said y. And the next thing that I'm going to say is I'm going to say that measure of z plus measure of y is 180. And how do I know that? Okay, because good, yes, okay, good. They are originally, so this is z right here. Y and z are originally in the parallelogram. And these two lines are indeed parallel. And what you should see is that this is same side interior angles. Okay? So I have measure of y plus measure of z is 180. And that's because they're same side interior angles. Same side interior angles. And same side interior angles are supplementary, or they sum to 180, okay? Now I substitute. And I get measure of 1 plus measure of z is equal to 180. And this is indeed a straight line here, and that this is indeed a rectangle. Once you have that as a rectangle, you should see that this length is h. This length is still b. Right? This length didn't change. This is b. Or this length is b if you want. Because I just cut out whatever was over here and I put it over here. So this length, this whole length, is still b. And what's the area of a rectangle? Base times height. And we should see that the area of the parallelogram is the same as my constructed figure, right? So let's write a final concluding statement. Let's see if I can get a strange color for this. Okay, since the area of the original parallelogram is the same as the area of the constructed figure, because I just took this triangle out and pasted it somewhere else with nothing overlapping, and it's completely included, right? So since area of parallelogram equals area of rectangle, we have and the area of the rectangle is base times height, then we know the concluding statement. We know the concluding statement is that the area, we know area of parallelogram equals base times height. And we're done.